There are places in the universe where even light will never reach another star. Not because it's blocked, not because it's absorbed, but because space itself is stretching faster than light can travel. But what would it actually feel like to exist in the most isolated place imaginable? A place with no past, no future, no hope of ever being found. We're going to explore the Boötes Void, one of the loneliest regions in the universe. We'll travel to intergalactic space, where the nearest galaxy is millions of light years away. And then we'll go somewhere far worse, beyond the cosmic horizon, where you're not just alone, you're erased. Cosmonauts, this one might keep you up tonight. Let's go. When we think about isolation on Earth, we imagine places like the middle of the Pacific Ocean, Antarctica, or the deep desert. But those places, they're practically Times Square compared to what exists out in the cosmos. Here's a number that should make you uncomfortable. About 80% of the observable universe is empty. Not mostly empty, almost completely devoid of anything. The universe isn't evenly distributed. Galaxies cluster together in massive filaments, like foam on the surface of a cosmic ocean. And between those filaments, voids. Enormous bubbles of almost nothing. Scientists call this vast structure the cosmic web. Think of it like a giant three-dimensional spider web, where galaxies are the threads and the holes between them are vast, dark, silent deserts. Understanding cosmic isolation isn't just about finding empty space, it's about understanding the limits of existence itself. How far can you go before you're cut off from everything? From light, from gravity, from time? Let's start with a place astronomers call the Great Nothing. In the early 1980s, astronomer Robert Kirshner and his team were mapping galaxies when they found something unexpected. A vast, roughly spherical region of space with far fewer galaxies than almost anywhere else nearby. It became known as the Boötes Void, one of the largest well-known cosmic voids in our local universe. It's about 330 million light years across. For scale, the Milky Way is about 100,000 light years wide. You could line up thousands of galaxies like ours across the diameter of this void. Now, it's completely empty. Astronomers have found about 60 galaxies scattered inside. But based on the average density of galaxies in the universe, there should be thousands in a region that size. One of those 60 galaxies has a name that looks like someone squashed their keyboard. I'm not even going to try to say it, but you can read it right there. Scientists sometimes refer to it as the loneliest galaxy in the universe. It's so isolated that if the Milky Way were in its position, we wouldn't have known other galaxies existed until the 1960s. But the void, as empty as it is, still has galaxies, still has stars, still has something. What if we went somewhere with almost nothing at all? Between the galaxies, there's a region called the Intergalactic medium. It's one of the most underdense regions in the universe. The air you're breathing right now contains about 10 to the 19th power molecules per cubic centimeter. That's 10 billion molecules in a space smaller than a sugar cube. Intergalactic space, well, that's less than 1 atom per cubic meter. Let me say that again. 1 atom per cubic meter. Each hydrogen atom out there has a private box larger than a refrigerator all to itself. Here's something wild. Intergalactic space is technically one of the hottest places in the universe. The gas between galaxies is heated to millions of degrees, but you wouldn't feel it. Temperature measures how fast particles are moving. When there's only 1 atom per cubic meter, those particles almost never hit you. You'd freeze to death in this hot environment because there's simply not enough matter to transfer heat. The baseline temperature of space, set by leftover radiation from the Big Bang, is 2.7 Kelvin. That's about minus 455 degrees Fahrenheit, just 5 degrees above absolute zero. In intergalactic space, you'd look up and see almost nothing. No sun, no nearby stars, just the faint smear of distant galaxies, millions of light years away. But, despite being nearly empty, the intergalactic medium contains more ordinary matter than all the galaxies combined. Between 50 and 80% of all normal matter in the universe exists in this sparse, scattered form. It's not that intergalactic space is truly empty. It's that empty is relative when you're talking about the cosmos. But even in the deepest void between the most distant galaxies, light can still reach you. Information can still travel. What happens when even that becomes impossible? This is where isolation stops being about distance and starts being about physics itself. The universe has a speed limit. Light travels at 186,000 miles per second. Nothing with mass can go faster. But here's the problem. Space doesn't have that limit. Space can expand faster than light. Right now, the universe is expanding. And not just expanding, accelerating. Driven by something we call dark energy, the fabric of space-time is stretching faster and faster. Galaxies aren't moving through space away from us. Space itself is carrying them away. At a distance of about 16 to 18 billion light years, space is expanding so fast that anything beyond that point is moving away from us faster than light can travel. This boundary is called the cosmic event horizon, and anything beyond that horizon is gone forever. Not just hard to reach, not just far away, causally disconnected. No signal, no particle, no information will ever travel from there to here, or from here to there. Cosmologists estimate that about 94% of the galaxies in the observable universe are already beyond our reach. We can see them in old light, images from billions of years ago, but we can never interact with them, we can never visit them, we can never receive any new information from them. They're already ghosts. If you were standing beyond the cosmic horizon relative to Earth, you could look back and see our galaxy, but no matter how long you waited, you would never see anything that happened after a certain point. From your perspective, Earth would appear to freeze in time, the light from it becoming more and more redshifted until it faded into invisibility. You would be watching a civilization slow to a stop, trapped in your past forever. And that's the present. What happens in the future is even more disturbing. The universe is getting lonelier, and it's never going to stop. Right now, we live in what astronomers call a golden age of cosmology. We can see billions of galaxies, we can detect the cosmic microwave background, the afterglow of the Big Bang. We can measure the expansion of the universe and understand our origin, but that window is closing. In about 100 billion years, every galaxy outside our local group will have crossed the cosmic event horizon. The Milky Way and Andromeda will merge into a single mega galaxy called Milkomeda, and beyond that, nothing. No distant galaxies, no cosmic microwave background, no evidence of the Big Bang at all. Future astronomers, if they exist, will look up and see only their own stars. They'll have no way of knowing the universe ever contained anything else. Physicists Lawrence Krauss and Robert Scherer calculated this future in a paper called The Return of the Static Universe. Their conclusion? Well, in 1 trillion years, the universe will appear static, unchanging, and completely alone. Dark energy will have erased the evidence of dark energy. Eventually, even stars will die. In about 100 trillion years, the last red dwarfs will burn out. The universe will enter what's called the degenerate era, where only stellar remnants, white dwarfs, neutron stars, and black holes remain. Then the black holes evaporate via Hawking radiation. This takes an incomprehensible amount of time. A black hole the mass of the Sun would take 10 to the 67th years to evaporate. Supermassive black holes could last 10 to the 100th years. After that, the dark era, a cold, empty cosmos with nothing but scattered particles, photons, and electrons drifting apart forever. So what does this all mean for us? Right now, in this moment, we can see the universe. We can measure it. We can understand it. We're living in a special window of cosmic time where the evidence of our origin is still visible. But in the far future, our universe will erase its own history. The most isolated place you could ever exist isn't a location, it's a time. It's the far future, when the expansion of space has stretched all connection beyond repair. And here's what I want you to think about. If a civilization existed beyond our cosmic horizon right now, one we can never know about, does their existence matter? And if it does, what does that say about the meaning of existence that we'll never discover? Drop your thoughts in the comments. I really want to know what you think. And if you want more content that makes you question everything, subscribe. We're just getting started.